Hello everybody, today we'll discuss about analysis of factorial experiment using completely randomized design for 2 and 3 factors for multiple response variable at once in our studio. In order to do that, you have to incorporate Doebioresearch package into our studio. And I already imported my data. My data name is NAP, which contains 7 columns and 24 entries, starting from replication ending with SY. So the three factors are nitrogen, phosphorus, and potassium, while yield, planted, and SY are my response variable or dependent variable. So the first step is incorporating this package to our studio by tapping library and write the package into parentheses. Then check your structure. So when you're checking your structure, here is replication, nitrogen, phosphorus, and potassium are not factor, so you have to convert into factor by using as.factor function. So type your data name, attach the label that you want to change into factor. So here is I use the dollar sign and is equals to, then I use the as.factor function in order to convert replication. So do for nitrogen, phosphorus, and potassium. So type this and submit to our studio. So let's check our data, whether it's converted or not. Yes, here is replication, nitrogen, phosphorus, and potassium are converted into factor from what they are. Then the next step is going to analysis. So in this case, I will show you how to analyze using the Doebioresearch package. So the model here is, if you want to compare for study design, here is F stands for the factorial, CRD stands for CRD design, to indicate the factors, the number of factors that they are going to analyze, and here is the factor. So data is your data name, factor A is your factor that you set first, and you set second will be factor B, and here is the multiple comparison test. You can write either 0, 1, 2, and 3. If you type 0 means there is no comparison test. If you type 1, it will compare the mean separation using the least significance difference, and if you type 2, it will separate the mean separation using the Duncan test, and if you type 3, it will work for honest significance difference test. So let's create the CRD design using Duncan test for one response variable. To do that, you have to use fcrd2 fact, then indicate your data name. Your data name is, in this case, my data name is NAP, and I will show you, or I will write 5. 5 means select the column 5. So column 5 means what? Let's see. Column 1 is replication, column 2 is nitrogen, column 3 is phosphorus, column 4 is potassium. Yes, column 5 is yield. So R by default will know that you are going to analyze the column 5. So type 5 here if you want just to analyze for what? For yield only, and indicate your factor that are going to be analyzed. So here is our data name is NAP, and attached from that nitrogen is our first factor, that means factor A, and do in similar fashion for phosphorus 2, and it's followed by comma, then by 2. 2 means their mean separation will be due on what? On Duncan test. If you type 1 for less significance difference, if you type 3 for honest significance difference, and if you type here 0, there is no multiple comparison test. So type this and submit to our studio. So it will give you detailed information. Yes, as you see, these are all detailed information. The first thing is that will give you its analysis of variance 1, and you will get this, and there is no statistically significant difference between the main effect of factor A means nitrogen, factor B means phosphorus, and their interaction is not significantly different. And it will give you R square and also detailed information of both factors A and factor B, and even their interaction, and also it will give you the normality assumption test for ANOVA. That means using the Shapiro-Wilk normality test. And as you see here, is the test is significant, so the assumption of normality is violated. And again, it will give you the mean square for error, degree of freedom, the mean, and coefficient of variation. Moreover, it also give you here the critical range, because Duncan it will give you more comparison ways. So again, it will show you the main effect of nitrogen, that means N1 and NO. In similar fashion, it will show you for the phosphorus. This will be the phosphorus. So the P0 and the P1. In both cases, the main effect as well as their main effect of nitrogen, and here is the main effect of P, are not statistically significant. Then it will give you detailed information for their what, for their interaction effect. So the interaction effect is also is not statistically significant like main effect of nitrogen and phosphorus. Furthermore, we can add other response variable by adding. Here is the second one is the column 6. So column 6 is, let's see what is column 6. 1 2 3 4 5 6. So column 6 is planted. So R again, it will add in addition of yield, it will consider for what, for plant height. So all things are the same with this one. So type this and submit to R Studio. So it will give you both for the yield as well as for what, for the plant height. Yeah, here is the plant height. As you see, here is the plant height, and again it will go for what, for the it will start from planted from this, and to the end is the planted section, and the remaining or the upper section will be for what, for the grain yield. And again, if you want to continue or if you want to add more number of factors, you have to convert 2 into what, 3. It will consider what, factor A, factor B, and factor C. All the things are the same. So again, I type here is 5 and 6. That means including the yield and what, for the plant height. So here is the nitrogen, here is the phosphorus. I add what, the third factor is potassium. So these two means it's the mean comparison, the multiple comparison test that I'm going to use is what, the Duncan test. If you type 3, HSCD or Hollow Significance Difference. So convert this one into 3, that means it will consider for what, for 3 factors. If you do for 2, you have to type 2 here. So type this and submit to our studio. Yes, so it will give you this result. Yeah, that is the ANOVA. The ANOVA, yeah, yeah, the ANOVA is this. Factor A, B, and C, that means nitrogen, phosphorus, and potassium. Interaction between nitrogen and phosphorus. Interaction between uh, nitrogen and potassium. Interaction between potassium and phosphorus and potassium, and their interaction. That means nitrogen, phosphorus, and potassium. So it will give you detailed information, their main effects, yes, their main effects for both parameters in this way. So this is all about factorial CRD for 2 and 3 factors and for multiple threads. So if you have any question regarding to my tutorial, you can address me through my email wabjiratasfan@gmail.com, or I will provide in the description box, or alternatively you can use YouTube comment box. Thank you for watching. Have a nice time.